In this video, we're going to look at the most general form of backpropagation.
If you followed along in the last few videos, then we've seen that we can write down the chain rule, which we often use in neural networks, with this kind of general prod notation, okay? And the other thing we've looked at is what happens when you have forks in neural networks. And if you know these two things, if you can write down the notation properly, and if you know how to deal with forks, then we get to this very general formulation of the backpropagation algorithm. And I'm just going to run through the steps here. I should emphasize here that this is the general backpropagation algorithm. So whether you're going to use a feed-forward neural network, a recurrent neural network, or a convolutional neural network, this is what's going to happen on the inside when you're doing gradient updates and when you're learning the parameters of these models.
So what we do is we start with accumulators for all our input variables, and we set them equal to 0, okay? And this 0 can be a scalar, a vector, a matrix, or a tensor, depending on the variable hue. We then do a forward pass exactly as we did before, where we start at the inputs of the computational graph, calculate the outputs of each operation, and store these values. We will use these values when we're in our backward pass. The backward pass, we start at the output of the graph and move backwards. For each operation, for each little block or node in the graph, we determine and calculate the derivative of the output variable with respect to each of the input variables to the operation. So if this is our operation that we're getting to, then what we are going to do is we're going to calculate dz, dv, and dz, du, okay? And we get both of these terms. And if we have that, then we know we can backprop into dv and into u, because we have delta z already. So for each of the input variables to my computational graph, I add this product of delta z du and my error signal to its accumulator. So I'm updating du. So I'm changing du, and for this operation, I'm adding this term here. If u also serves as the input to some other operation, and maybe I shouldn't draw this, but I'll do it, okay? Some other operation here that has some other output, then when I get to this operation, then I'm adding another term here that's captured by that equation, right? So, and if you use one more operation, then again, I'm going to add it. And that's, now you can really see why it's called an accumulator. Okay. Now, and I've mentioned this before, if you're going to use delta u, or the error signal, the accumulator for u downstream, right, you need to go back, and at some point you see, oh, I need this accumulator, then you need to make sure that it's final. In other words, you need to make sure that I've backpropped through all of the operations where I take u as an input. And that's it. This is the most general form of the backpropagation algorithm. You now know what accumulators are. You now know how to deal with forks in the road, and you also know about this prod operator, which makes things really nice and convenient to express mathematically.